Thank you, Ron. Yeah, and well done on positioning this. So my name is Jerome Wiener. I'm an app innovation specialist, which is just a fancy title for somebody who's really trying to make sure as many developers as possible feel welcome and included into our Azure platform. And so every day I deal with open source. I think Satya said it himself a couple of years ago. Every one of our large clients, every company is becoming a digital company and is starting to build themselves software, be it just an app to interact with your clients or app internally to use for employee engagement, for example. And what we've seen is just a lot of the innovation was coming out of the open source. And I think that's why our company 5-6 years ago really pivoted. I can share some things that you wouldn't be able to see maybe as much in the press, but even internally after the GitHub acquisition, we started all the Azure services that we build. The development for it is done on GitHub. Internally, we've inner-sourced some of these projects. So even myself, who's more on business development side of things, I can go and find what engineers are working on. I can submit feature requests. I could even contribute, build my own branch and contribute. And then we've seen just a lot of our IP also being open sourced. The functions runtime, things like this. More and more workloads are on Linux. 2/3 of the workloads on Azure are on Linux, and almost all the workloads that I work on run as containers on top of Azure Kubernetes, for example. But so embracing the open source also brings a very new paradigm in how do you secure software and its development today. And this is an area where we've partnered up with GitHub post-acquisition, and we want to help you as you build more and more to build secure. And so I spent the first 10 minutes talking about DevSecOps, and then I'll talk a little bit about other things that we've announced at Build 2 weeks ago. So cybersecurity in the context of shipping software yourself. One figure that's always scary, it takes only 3 days once a vulnerability is out there to be exploited. So if you shipped something with Log4j, 3 days after the 0-day went public, you would have been attacked. If you ship today something with a vulnerability, it won't take long until the vulnerability is sniffed out and then potentially abused without you knowing. And that gives bad actors access to potentially your underlying systems. A challenge that we see, especially a lot of us coming from more of a developer background, is just still a friction between the development team and the security team. So 62% of enterprises don't have yet integrated the security in the development phase. 58% of our clients do not collaborate between these two departments. And really what we're trying to address is to reduce cyber risk by shifting security left. So bringing security concepts early in the development process so that the human is trained to develop secure software from the get-go. Because fixing a bug that is security related in production is going to cost you 60 times more than having it caught in development before you shipped your software. So the concepts that we evangelize, and it's out there, other big players are also running with this, is DevSecOps. So DevOps has been around for 20 years, the union of people, process, technologies to deliver continuous value to users, and now infused with security. So a way to bring security first mindset and a culture of security first and a high degree of automation into the entire life cycle of development. The goal here is to reduce remediation time. It's to integrate with and secure your existing tool chain and then quickly identify new threat vectors. What we've seen, and if you look at the latest 0 days that have startled the world, is a lot of them were in components that were open source, right? And when you're going to build your next app, your next digital assets that you're going to ship, you're going to take already a lot of packages and dependencies that are open source and then bundle them, add your unique IP, your own recipe, and then ship it. So you need to start thinking about how do I secure my pipeline of softwares that I take and upon which I build, and also how do I drive visibility into that, so that when the next 0-day gets published, and not if, when it does get published, you want to be able to quickly see, okay, what are all of my projects that are using, that have a dependency on exactly this, and that I need to remediate as soon as possible. And that's exactly where the power of GitHub and the power of Azure is going to come to help. The interesting thing that we're trying to do here with products like GitHub Advanced Security is, how do we make security the focus or a focus of the developers without stalling them? Typically, what I've seen is we get pulled into to conversation where the developers have finished building the app and now they're doing the cybersec review, and then they get demolished by the team, and they say, go back to square one, redo this, and it's just this waterfall system that's just taking forever. And if the developer had known at the early stage of his projects that he wouldn't be able to ship that way, he would have worked around it from the get-go. So how do we keep developer velocity high? How do we eliminate complexity from them and empower them to contribute, while the team around the CISO can have advanced forensic into the code development, partner with them, and then teach them and enable them to proactively hunt for threats. So if we look in terms of a portfolio, how it could look in a more mature customers that has adopted both GitHub Advanced Security and then some of the Azure Security Center. So if you were to build on Azure, similar concepts you could probably bring or cobble together on other hyperscalers. I will say that in the sessions that we just heard with Jeremy, Arc, the way to bring down Azure services to any infrastructure, we have clients bringing Azure Security Center policies all the way down to EKS clusters or GKE clusters, for example. So you will be able to bring some of these concepts down to any infrastructure too. So how the whole picture can look is, your developer works in his IDE, or he uses CodeSpace or Jumpbox, works against his GitHub repository, and then he'll have 3 key areas of features from GitHub Advanced Security. One is code scanning, so continuously scanning in the code to find any malpractices. For example, I am just taking a string from an API and building a SQL query based out of it. That's known a very easy way to do a SQL injection attack this way. So this would get caught. The next one is secret scanning. Am I shipping any API keys, or am I shipping any passwords or storage keys in my code that would immediately get flagged? And then you train your users to use a key vault, where you put the secret, and what you ship in your config file for your app is actually just a pointer to that secret. And then the dependency scanning is what's gonna let you find out where have you taken dependencies on Log4j. So this is gonna come from advanced security, and it's really in front of the developer. So as he writes code, as he does commits, he will get policies and warnings so that he can change the code as he's building it, and it's not something that comes after the fact. And then you can really boost this with the security concepts that are baked into Azure. So in Azure, you'll have your identity layer with Azure AD, obviously, monitoring and app configs that let you use variables instead of secrets in your entire CI/CD pipeline. And then you have a core concept like the policies that will use the ARM API to enforce things. Like you can have a policy that says no public endpoints on any storage accounts. Flag every storage account that I have that is still publicly available, for example. So you can really drive visibility and then accountability by going to the owner of these accounts or of these VMs. And a way that Security Center also makes it more digestible, because we've seen a lot of their great cybersec tool and scanning tools, but then once you have all of these alarms triggered, how do you take steps to remediate and not overwhelm the team? So the secure score is a concept that we've launched, where you get a scoring on, hey, you're at 80% secure. If you do these 5 things, you could get to 85%, for example. And then we have tools like the firewall, WAF, and baked-in DDoS protection that will help you just be able to run customer-facing or public internet-facing assets with the confidence that you have the power of our hyperscale infrastructure to help protect you. And then Defender is going to run scans. For example, you've shipped a container, it will be able to observe how your container is scheduled on a Kubernetes cluster. Is it running as root, for example, which is a no-no? Is it trying to grant itself higher permissions against the Kubernetes APIs? All of this would be picked up, and then the security center would flag it. So that's where we try to bring together Azure and GitHub to give you the most secure way to build and ship software. One thing I do want to point out, GitHub Advanced Security, so what we talked about, the secret scanning, dependency scanning, code scanning, all of this has been announced and is coming to Azure DevOps. So if you're on Azure DevOps, have not switched to GitHub, no plans to switch to GitHub, you will be able to benefit from this too. So this is now in public preview. GA date probably is another 6 months out, but public preview is usually stable enough for you to be able to start using it. All right, so this is everything around GitHub and how to build yourself on open source in a secure way. Now I thought in the next 10 minutes I would go through some of the other things that we do here at Microsoft to try and make developers more productive. So I'll talk first about the GitHub Copilot, and then I go into briefly code spaces and DevBox, and then a very cool new set of capabilities with deployment environment. All right, so GitHub Copilot. We've heard all the hype about OpenAI, about generative AI. GitHub, very early on, this is a product that's already been in the market for over 6 months now, has brought these OpenAI models to help you build software. So if you look at the types of OpenAI models there are, they have different capabilities. Codex is specifically tuned to help you write code. DALL-E is specifically tuned to help you generate images, for example. ChatGPT is specifically tuned for conversational flows. So GitHub early on used Codex to help you build or write code and be context aware. So you can type in, write me a function that will call a PostgreSQL and submit the query. And I want the query to be, get me all the accounts that are in the Northeast. And from this, it will be able to auto-generate the code that you need. And it also is aware of all the context within your IDE, which means in this example, you can see that he can pull variables or other functions that are defined within your structure. Now, the next stage of this is we're bringing ChatGPT models to help augment this. So let me try and run this with no sound. This is going to be the new GitHub Copilot experience that is enhanced with a more context and chat awareness. So what you're seeing here is in my IDE, not only do I have enabled GitHub that can look at my code, help me, I also have a chat interface where I can ask him, hey, can you write me the unit test for all of this? And then GitHub Copilot will be able to write this for you. Or you say, how you define variables in Python? He'll be able to, in the chat next to your IDE, give you samples, and you'll be able to just have them populate over to your IDE. So this has been a huge resonance with developers. Almost all of my accounts are starting to use this. It makes developers, especially for repetitive tasks, so much faster. And I think the biggest feedback from developers has always been it helps write unit code, and nobody wants to write that. So that's GitHub Copilot. Other things where we can see the power of a hyperscaler together with GitHub. An example of this is code spaces. So what you've seen here in this video is instead of forking over a project into my SIG client where I've installed all of the tools that I need to do my React Native front-end development and this type of backend development, here I can, from within GitHub, define a code space, which means Azure, the platform underneath, will spin up a container that will have all the dependencies that you need and create a fork of this project or a branch of this project. so that you can start contributing to the project from any type of SYN client. So you don't need to install any of this. Here, what happens is you basically launch an RDP or an SSH into a container that has everything installed, including secrets and passwords. And basically from a phone, you could start contributing code. If you need a more robust experience, Jeremy was talking about Windows 365. There is now a flavor of Windows 365 specific to developers. So think again about if you're working IT, you have to give them clients and they keep on coming to you and say, hey, I need to be able to install this package. I need admin rights to install this. I need this. And it just takes forever to enable them. And then they have everything and they move to the next project and they need more. And they end up with these super convoluted big machines that have a ton of stuff installed just so they can work on multiple projects. What if when they switch context and contribute to different projects, they also switch the clients that they use? That's exactly what DevBox is going to do. So you'll have a ready-to-code, self-service virtual client that's powered by Windows 365 that you can make project-based. So you have this big .NET project. Okay, for a .NET project, I'm going to need all of this. This is part of my image configuration. You then switch over because you're going to do Node.js. You have a different client defined that will have everything you need for Java. And so a developer then can go into his developer portal, pick a project that he's unable to work on. He'll see these are the dev boxes that are defined for this project. Click on schedule the dev box. It spins up. I remote into it. I can start contributing code. And then when I switch projects, because this afternoon I'm going to work on another project, it will unschedule this dev box, spin the next one up, and I can go over to this one. It's a really powerful way to bring virtual desktop concept to the developers. So that's all the stuff we do. And I don't see, Ron, if there are questions, but I'm happy to take a quick break on questions or go to the last topics. That's
there was one question that I know that Jeremy started to answer this, and this is just a broad-based question, which is how can you be confident that open source software is secure?
So that takes a lot of players and many people in the industry to be able to help you there. But in the open source world, there are companies that are continuously doing pen testing on different packages and etc. Every vulnerability is published, and there are these shared lists that are refreshed every day with vulnerabilities. And then tools like GitHub Advanced Security, they query these lists to find out are these packages secure or not. And then you could, on top of it, have your CISO team say, when we do work on Python, we only want to allow these packages, for example, or when we do work on these projects, we only want to allow this. But it is a team effort, and there will always be 0 days that have not yet been caught.
And I think
then it becomes.
Yeah, I think the real answer is that it's very much dependent on your environment, the specific software using, the specific application. It's actually one of the good things about the Microsoft GitHub partnership, whereby GitHub now has tremendously greater resources to help validate, monitor all of the open source platforms. And then what you can do is, even as you're using open source solutions, you've got the availability to integrate it with proprietary and just as secure, if not more secure, Microsoft solutions to make sure your environment basically has the best of both worlds, whereby you can talk to Jerome, we can schedule follow-up discussions, and you can figure out, well, which partner is the best qualified to help deploy your customized solution. And again, I'd encourage you to just, in your follow-up note, just let me know where you're working. This is more for Joe, and then I'll make the introduction to Jerome.
That works.
Okay.
The last thing I wanted to briefly touch on is deployment environments that has gone generally available 2 weeks ago. Deployment environments, think about it like this. You have a team of developers, they're building apps for the cloud. they need to be very quickly able to spin up infrastructure and destroy infrastructure. So think of it like this. They have a stable project and now they're adding in new features. Ideally, they can create a new branch in GitHub and then spin up the entire environment, this entire copy of your app with real data, just staged in a UAT or dev environment, test their feature, and then once they're convinced it works, destroy this environment and commit, do a merge request into the main branch of your environment. And you want to empower developers to be doing this while making sure that you still enable zero trust and build in governance in these environments. So give the developers superpowers, still with a lot of responsibility and accountability. And this is exactly what these development environments will let you do. Basically, it's a way to cobble together infrastructure as code together with GitHub pipelines or Azure DevOps pipelines to be able to quickly spin up and quickly destroy environments and make the developers very productive. And this is a conversation I have with a lot of the teams that do platform engineering. It's really shifting, not taking an infrastructure point of view on how you do platform engineering, but more of a enablement for developer kind of point of view. So a lot of companies are now investing in building in these internal developer platforms that let you do exactly this. I'm a new hire at your company. I'm gonna work on this React project. How quickly can I start committing code? And all the magics that needs to happen underneath, spinning up infrastructure on Azure, giving them the right access rights, all of this will start being addressed with development environments. And then I finish just on this quick note, because that's always the next question I get. Do I need to use ARM or can I use other providers? So Terraform is going to come soon. So we see Terraform for infrastructure as code is still very much one of the preferred tools. You'll be able to do this with Terraform.